Yeah, welcome back to Hudson Engineering Academy. Please don't forget to subscribe so that you get not to miss any video that I'm going to post next. So we are still continuing on our lecture series that is on the topic torsion. So this is problem number 4. Please don't forget to watch the previous video so that you understand all other videos coming up next. So the question is, a solid circular shaft is to transmit 300 kilowatts. So our power is given 300 kilowatts. This is equivalent to 300 times 10 to power 3 in terms of watts. Then number of revolution per minute is 100 revolution per minute. If the shear stress is not to exceed, tau is not to exceed 80 mega Newton per meter square, that means it is 80 times 10 raised to the power 6 Newton per meter square, which is the same as what? Pascal. So what is the question asking us to find? Our first question is, that is A part, is asking to find the diameter. So that means we need to find what? We need to find D. So our torsion equation is T by J is equals to tau by R is equals to d theta by L. If I take the first two, I don't know the value of T, but I gave you last time the formula that says P is equals to omega T, where P is equals to 2n pi divided by 60 times T. From this expression, I can find the value of what? Of T. So I'll find T will be equals to P. My value of P is 300 times 10 raised to the power 3. That's the value of what? P. And I cross multiply, I will multiply this by 60, then divided by 2 times n. Expression, value of me is 100, then times what? Times pi. So this will give us the what? The value of T that we want. So according to my calculator, I'm getting 28647.89. 28647.89. This is in Newton what? Newton meter. So this is the value of T we have got. Now we shall proceed and use the expression to come out with the value of what? D. In this case, my T, I'm going to take this first part. Okay. My T is what? Is this value? 28647.89. Okay? Divided by J. Last time I gave you the formula for J is pi by 2 raised to the, multiply by R to power 4. But R is the same as D divided by what? By 2. Everything to power 4. Is equals to J, but in this case, no, not J, tau. This is tau, not J, please. Okay? Tau. So our tau is given to be 80 times 10 raised to the power 6. We are dividing it by R. R is the same as D divided by what? By 2. So from this expression, we can simplify to come out with the value of what? Of D. It is quite simple because I just need to rearrange it. This with d to power 1 will become d to power 0, then this d to power 4 will become d to power 3. But remember, it is only for d, but 2 is what? Raised to power 4. So that is 16. 16 times what? 2 will be 32. So this, if you simplify, the value of d is coming to be what? 0.122 meter. 0.122 meters. Please try to simplify this. It's quite easy. Just simplify this, raise this to power 4, simplify it, and get D is coming to this, which is also equivalent to 122 in millimeter. Alright, so this is our first part, finding the diameter. What is the second part? The second part says, if the shaft is to be replaced by a hollow one. Okay, hollow shaft. If I have this and I have this, so you find that the middle part is hollow. So since the middle part is hollow, there is internal diameter. Okay. Then there is also what? External diameter. If I can draw like this. So this I call it capital D. Then this I call it small d. So the question B part says, if the shaft is to be replaced by the hollow one, whose internal diameter is 0.6 of the external diameter. Meaning that the internal diameter, which is small d, is 0.6 of the external diameter, which is capital D, if I take in that case. So this will help us for the second part. So allow me just erase this so that it can give us the space for doing the second question. Well, this second part is important because I have to explain for you how we use hollow, because we have two diameter in hollow shaft. Okay? So the question is telling us that if the shaft is to be replaced by the hollow one, so let's deal with the hollow one. The hollow shaft now. Okay? The hollow shaft, whose internal diameter is 0.6. Now the difference is that when you're finding what? When you're finding J in the hollow shaft, J is given by pi out of 2. And then instead of R, remember it is D by what? D by 2. So this D by 2 raise it to power 4. Okay. But in hollow shaft, this expression is supposed to be pi by 2. Okay. Then D by 2 raise this to power 4 minus small d by 2 raise this also to power 4. Okay, because this is the external diameter and this is the internal diameter. So when you simplify this expression for hollow shaft, our J is supposed to come to pi by 32 into capital D to power 4 minus small d to power 4. This is what we got, what is different from the what? The other solid shaft. So if we now know that this is the expression, what is the question saying? We have to find the what? Find the diameter, external diameter. External diameter means for the hollow shaft we are finding the value of capital what? D. Now, still using the torsional equation, T out of J is equals to what? Is equals to tau out of what? R. So we know the value of T. Okay? I remember that our value of T was 2, 8, 6, 4, 7, then 0.89. We're dividing it with the value of what? J. Our J is pi by what? By 32 into D, capital D. Remember we're finding that value of capital D. Then minus small d. Our small d is 0.6 capital D. So this is 0.6 capital D. Everything raised to the power 4. Then we are equating this to what? We are equating this to tau. But our tau has been given. Okay. If the shear stress is not to exceed what? 80. So that means this is going to be 80. But mega means times 10 raised to power 6. Then we are dividing it by what? By R. But remember this is what? R is the same as D divided by what? By 2. So these are the expressions we need to simplify. Okay, so I will go as far as simplifying this. That means I will have here what? 2, 8, 6, 4, 7.89. Okay, so remember this is in the denominator. I can take it up times 32, right? Then if I take the whole of this part here and bring this one here, so that means I will remain here by pi. Then times, bring this one down here, 80 times 10 power 6. Then remember this 2 is also in the denominator, take it up. That means I multiply this by what? By 2. Okay? So I'll simplify this part. And then I'm remaining with what? With this part. So this is equals to D to the power what? 4. If I pull it out, is equal to 1 will remain here. Then minus 0.6. Everything here is also raised to the power 4. So you divide this by what? By this capital D. So if you simplify that, I hope I can erase this part to help me come to the final answer. Okay. If we simplify this, we shall have D to the power power 3. This will reduce this. Shall have d to the power what? To the power 3. And if you press this carefully, okay, if you press this carefully, d to the power 3, I mean, just getting the cube root on both sides after getting the final answer. Okay, this our value of d, the final value of d is coming to 127.96 in millimeter. Alright, yes, so this simplify this, confirm this from your calculator. It is not very hard, very simple, just follow up this until you get this final value. So that is the difference of solid shaft and hollow shaft. So follow the calculation clearly, especially when finding the polar models. Okay, thank you so much for listening, and please do watch the previous videos so that you can understand this one. We shall yet continue to solve some more problems, so continue. Don't forget to subscribe to Torsion Engineering Academy always. Thanks.